So now we're going to move into the energy segment of the day, and I would like to welcome Gadhu Sundaram up to the stage for our keynote on energy. Gadhu is the Vice President Application Services at NTT Data UK. Welcome.
Good morning, everyone. Name's Gadhu Sundaram. Annette has already talked about the Green Software Foundation, and I'm going to be talking about standards for green software, just focus on standards. I work as a technologist for NTT Data. I'm a keen conservationist. That's a topic for another time. And I represent my company in the Standards Working Group of the Green Software Foundation. So what I'm going to talk about today is the journey that we went through for the past 2 years in creating standards that are required to define, run, build sustainable software applications. Now, where do we start? So we are super proud as technologists. We're super proud of building lots of digital solutions that make a positive impact on society. But at some point in the last few years, we sort of realized, okay, digital does not equal green. There were a lot of scary statistics that came out. We heard a lot earlier. So the cloud alone has a larger carbon footprint than the airline industry, and that's increasing, right? And here's another scary statistics. For every 60 minutes of streaming of video, that's 1,000 grams of emissions, right? And then you realize that for every digital transaction needs energy, physical infrastructure, and a device to run. Now, as technologists, this was a motivation. We had a duty to make sure that the digital solutions that we build don't have an impact on CO2 emissions and are not exploitative of the planet's natural resources. So what do we mean by green software? So there are two ways of looking at how software can impact climate change. There's a lot of really good solutions in terms of, measuring, monitoring, analyzing emissions that software can be very useful for. And you also have a lot of smart solutions. So you heard of smart cities, smart buildings, where software can be used positively to impact climate change. But then we also have to look at our own backyard. Are the services that we are building actually contributing negatively to emissions? And that's where we wanted to concentrate. So that was a starting point. So when we started off with, okay, you can't measure what you can't improve. So the first thing is to create a standard for actually measuring the impact. That's where you start. And we looked at a few options. The most obvious one was the greenhouse gas protocol, GHG protocol, very widely used. Every regulation now uses the GHG protocol for the CO2 equivalent, like for the emission measurement. There are also organizations like GESI have also created very specific guidelines for the use of GHG protocol for ICT companies. So this covers hardware, software products, software services, etc. So all of this was already there. So why not just use the GHG protocol? Why did we have to go and create something new, right? So GHG is an accounting standard created by accountants and used by accountants. Sorry for the accountants here. We technologists couldn't really understand it. It wasn't granular enough. So you had monthly, quarterly, and yearly totals. And I'll talk about why that wasn't really enough for us. And it was looking at the rearview mirror. It looked at what happened in the past quarter or the half year or the month. It also includes a lot of market-based measures. While they are very important, they're financial instruments designed to neutralize or offset carbon emissions. So that's part of the measurement. But that couldn't be really used by engineers. So what we wanted to create was an actionable approach that could be used by software designers, developers, etc., to measure the carbon impact of whatever they're creating. Right? And we wanted something real time. As software engineers, we can't wait for a month to find out what's happened. We wanted something in seconds. So, and we are used to a lot of sort of iterate working. So we wanted to test out the impact of our actions immediately. And we wanted something, we wanted a score, and I'll tell you why that's a big difference, a score rather than a total. So the GHG protocol gives you a total for your business, for your digital transactions, the total carbon footprint. The total can depend on lots of different factors. It depends on the adoption of the services that you're building. It depends on whether the business is doing well or not. If let's say that your footprint increases, that's probably it's probably not because of some intervention that we've done as a software engineer. It's because the business is doing well, or the adoption rate has increased, right? So we wanted something like a score, and that's where we wanted to find out the impact of per API or per server or per application footprint, right? Which will give us feedback on, okay, what's the impact that my change has made, right? So that was a key difference. And we wanted to focus on elimination. We wanted to reduce rather than offset. So, and this was why we came up with the new standard, like SEI. What was the starting point? We distilled the software principles that we had to these 3 levers that a software designer or a coder could use. So one is energy efficiency, hardware efficiency, and then carbon awareness. I'll talk a little bit more in detail about each one of these. So we came up with a simple formula and a simple standard called the Software Carbon Intensity Standard that includes these levers. And when you use this to measure, you know that what's the overall impact of your application is. Now there are 4 main things to remember, and I'll talk you through that. E, I, M per R, and I'll talk you through sort of each of these aspects. The first one is just energy. It's measured in kilowatt hours. So this is this denotes the total energy that your software uses in terms of kilowatt hours. And I'll tell you that what can be done with that. So we are looking at sort of how efficient is an application in using energy. So there are various points at which this will be impacted throughout the software supply chain, I can say. It could be at the data center, it could be overheads, it could be the servers, it could be the operating system or your app. So we wanted to capture that. We wanted to capture that in one number and denote it in terms of kilowatt hours. So that's the first variable, E. There's also some things you can use, for example, energy proportionality. What we found was the utilization did not linearly increase with power, right? So you need to, there are lots of interventions that you can make by just making, looking at this particular sort of utilization or energy efficiency. So one is, okay, so the first one, E, was the energy that your software application used. The second is the grid carbon intensity. So this electricity has to come from the grid, and how green is that electricity? So we measure it in terms of grams CO2 equivalent per kilowatt hour. So how green is that electricity? Now, the dirtiness or the cleanliness of the electricity varies by location, and it also varies by time. Now, what this enables you to do as software engineers is to do something like carbon-aware computing, where Annette talked about it earlier. You do more where the carbon intensity is low, and less when the intensity is high. So you can either do shift your load geographically or temporally, so you can shift it in the same location in terms of time, or you can shift it to different locations. So that's a lever that you can use. The third one is embodied carbon. So embodied carbon here is, so for everything, for software to run, you need hardware. So you need servers, you need devices, you need network equipment. And software, there are emissions during the creation and destruction of all this hardware. So we wanted to capture that aspect as well, so that you can make choices in actually sort of using hardware better, using hardware sort of which has got less embodied emissions, etc. So here's a graph that shows that the production, so the emissions during the production of devices is much, much greater than the use during their lifetime. So which is why embodied emissions are so important to capture. So there are a few levers that you can use. One is extending the lifespan of hardware. So here's an example of how you can extend the lifespan of your hardware. Typically, sort of the lifespan of servers is 3 years, but then there's a lot of value in extending the lifespan of those devices. The second is increasing the utilization. So stack up applications. So avoid wastage just in terms of don't buy another server just because you want some space, right? So stack up applications and minimize the use of servers. So these are examples of how you can use this particular aspect of M. And what we want, and because that sort of software applications are so complex and they are different, we wanted to provide the flexibility to software engineers to use their own scalability factor. So this measurement can be used per application, per user, per API, or whatever sort of you could think of. And so where are we now? So there's a lot of, among our member organizations, so the Green Software Foundation, there's a number of case studies where we've used it across large organizations, across banks, across sort of wide portfolio of applications. So adoption is increasing. And the great thing about being as part of the Green Software Foundation, which is under the Linux Foundation, is the open principles with which we work. So there are a number of my colleagues in this audience, so Chris Lloyd-Jones, just to mention, we are all sort of, we come from across, we are competitors, hyperscalers, suppliers, all of us working together towards creating this under the open principles to create something that's useful for the entire software community, right? And finally, and there's a rich ecosystem of tools being built, all open source, and there's probably sort of going to be explanations of these tools later on, examples of which are the Carbon Aware SDK that helps developers real-time tap into the grid, to the electricity intensity, and the Impact Engine framework that helps in putting together a kind of composable set of models to help measure SEI. Right? And I'll end my note with welcome you join us on this journey in the Green Software Foundation, and we can talk during lunch. Thank you.